Alright, so today in section 4.1 we're going to talk about one of the three methods for solving a system of equations with two variables. One of these methods is the graphing method. So this is our system up here. We've got 4x plus y equals 6 and y equals 2x. And we're going to start by graphing the line 4x plus y equals 6. And we're going to do that the same way we did on graphs in 3.1. We're going to start by finding the x and the y intercepts. Right, so in order to find the x-intercept, we're going to set y equal to 0. So we'd have 4x plus 0 equals 6, okay, which would leave us with 4x equals 6. If we divide both sides by 4, we'll have x equals 6 divided by 4, which can be reduced to x equals 3 over 2, or 3/2. Okay, so our x-intercept is at 3/2, 0. Okay. Now we're going to go ahead and find the y-intercept. If you remember, we find the y-intercept by setting x equal to 0. So we will have 4 times 0 plus y equals 6. This term drops out, so easy enough, we're left with y equals 6. So the y-intercept for this graph is at the point 0, 6. Okay, and then lastly, we're going to find some arbitrary point on this line. We're going to do that by setting, let's say, x equal to 1. Okay, so we have 4 times 1 plus y equals 6. And we have 4 plus y equals 6. Subtract 4 on both sides, and we're left with y equals 2. So another point on the graph is that where x equals 1, y equals 2. Okay, so if we graph this line, and we'll look, let's see, if we go x is 0, there's a point, and 3/2 0 is roughly right here, and then there's a point at 1, 2. Okay, so our first line comes down through those points like that. Okay. Alright. Those are supposed to be arrows, even though. There we go. Alright. Okay, now we're going to tackle the other equation that we have, the y equals 2x. I'm going to erase all this. And then we're dealing with y equals 2x. Okay, now this does throw some people, but just try to bear with me here. Okay? So first we're going to find the x intercept, which we would find by setting y equal to 0. So 0 equals 2x. If we divide both sides by 2, we have 0 equals x. Therefore, the y-intercept is at 0, 0. Now, if we were to do the same thing in the other direction, we'll go ahead and do it just to illustrate the point. We'd have y equals 2 times 0. So if we were solving for the y-intercept in this case, we'd have y equals 0, which as you can see is the same point. So if you ever come up with the origin as either your x or your y-intercept, then you don't need to bother finding the other one, because it will also be 0, 0. Okay? However, we still need 2 more points in order to graph this graph accurately. So we're going to go ahead and again substitute arbitrary values in for either x or for y. I'm going to go ahead and use x. So I'm going to substitute 1 in for x. So I would have 2 times 1 equals y. Therefore, when x equals 1, y equals 2. So one of my points is at 1, 2. Do this again. Lost part of my y there. All right, do that again, and I'm going to use x equals 2 this time. So we're going to solve for y equals 2 times 2. In other words, we're at x equals 2, y equals 4. So another one of my points on this line would be at point 2, 4. Okay, so if I was to graph this equation, I have a point at 0, 0. I have a point at 1, 2. I have a point at 2, 4. So my other line comes up like this. Okay. Now, where those two graphs intersect, right here, that is the solution to this equation, okay? And the reason that that is the solution is because this is the point, right here, that satisfies both of those equations at the same time. Meaning if you put that value in for x, value 1 in for x, you will get the value 2 for y in both equations. Okay, so this is how we can find the solution to a system of equations by graphing. If you have any questions, please let me know.